Welcome to part 2 of our start to finish walkthrough, where we're also tracking wish list items for future versions along the way. It's Australia Day today. I'm wearing my Australian band t-shirt, and I'm going to try and get this done before we head out to see the fireworks. Now, speaking of future versions, 6.7 was just released last week as a beta, so I'll show a couple of things on that version today. So this will be like one of those box opening videos, since it's my first time running through a model in 6.7. So now that we've got our project set up from part 1, today we're going to dive into RAS Mapper. For those new to HEC RAS, RAS Mapper is a standalone GIS program. It can be used with or without water. It's got lots of useful functions, even if you're only going to be using it as a mapping program. We'll step through some of the cool features here, but keep in mind it looks like RAS Mapper will gradually be getting phased out. So whether you're a beginner or you're already experienced with RAS Mapper, I think we're all going to want to start trying out HEC RAS 2025 in the meantime. This one's still an alpha version at the moment, but with a bit of practice, we can get to use the new features as they get rolled out over the next couple of years. If you wanted to try out that new interface right now, you might want to step through some of the links that were shown in part 1 of this video. So give that chapter a watch for some more resources, or if you want to take a deeper dive, check out the brand new Full Momentum Vodcast, episode number 36. So just as a quick review from part 1, we downloaded, installed, and opened HEC RAS 6.6. I've now done the same for 6.7, so I'll go ahead and open the project that I created. Now the installation steps are all the same. Since it's beta though, I'm going to keep both versions open since I usually don't like to deliver a project on a beta version. But I'll have to repeat a couple of the steps that we did before. Under options, I'm going to set my unit systems to be SI units as the default, and I'm also going to go back down here under my default project folder and set that one to be D drive Disneyland, which is what we did before. So now I've got 6.7 ready to go. But when I open this file, I'll go to the project and set the go back to the default project folder here, which is my Disneyland one. When I open this up, I realized one of the things I probably should have mentioned before is the title. Right now it's not very descriptive. It just says Disneyland. And I also probably should have mentioned here the description field. Never leave this blank. Now, if you want to grab the PDF workshop guide, which I'll link to in the description, it includes some suggestions for what you might put in this field. I usually like to include the model purpose, the client, any data sources, my own contact details. Some people like to put the date of the last model run. Keep in mind, you'd have to be sure to keep this description current as you go. Otherwise, a bad or outdated description, it's probably worse than having no description at all. So I like to include some disclaimers, like not for construction. In our case, that's probably obvious. Maybe I'll just say made up here. It's a made up project. You'll see that this is still temporary. When it's maroon like this, when you save it, it will then be black. Now, if you expand this, you'll see you have plenty of room to be very descriptive. And if we wanted to get some more details in the title as well, we can edit that now. If you put in the title when you're first setting it up, the project, it'll start overriding the file name. We could have done it then, but I'll go ahead and change the title here under the file menu. So I'll go ahead and rename the project title here to be a bit more descriptive than just Disneyland. We'll say Disneyland Demo for the Solution. Now this can be pretty long. I think you get 40 characters and changing it is easy to do. Not so with the file name. If you need to change that after your project is up and running, you could do a save as or zip up as an archive or put it somewhere else, but I'd never recommend keeping more than one project in the same directory. So you might be better off just copying the whole thing over in your file explorer and then renaming the new folder to something else. That can be a real pain to change the project name later. So think about what you want to call it in advance. Before you do any modeling at all, make sure it's something that you think you'll be comfortable with after delivering it to a client or a stakeholder when it's all done. I think you get a max of 17 characters here, but sometimes you'll want to be more descriptive than that. 17 is the limit at the time. That may seem a bit short, but it's sure a lot better than the 8 characters that we used to get back in the 80s. So now we've got a PRJ file. Let's pull up Windows Explorer here with a bunch of subfolders in our Disneyland directory. And sorry, one of the things I also forgot to mention in the setup video is that I definitely recommend pinning whatever folder you're working on, not just as the default directory for HEC RAS, but also to the quick access menu here. You'll probably be referring to the folder a lot while you're working on a project, so that's done now. Now, if you're following along live, make sure your project folder sits somewhere on a local drive that you can easily find. I usually don't recommend using OneDrive or SharePoint or any cloud-based directories when you're first setting up a project. Sometimes it'll be fine, but some people have had issues getting everything linked up and running remotely. So anyway, at this point, let's get back to our walkthrough. We'll open up RAS Mapper, which is this middle button, number 14. Once it's open, it should get its own icon down here in the taskbar. Now, when RAS Mapper opens, it's totally blank. This is where we'll see our map, but where in the world are we if we just try to hover the mouse around? Well, if we try to turn on our aerial imagery to find our location, which you can do here under Map Layers, if you right click on it and try to add web imagery, you'll get an error here. It says that we haven't set our projection yet. So I'll say okay, and let's try to set a projection. But what do we use? What should we pick? And why does the projection actually matter? Well, I tend to really harp on this point a lot, but it's absolutely crucial to get the projection right from the beginning. Don't even start your project until you know what you want the projection to be in. If you don't know, go back to the client, ask them what projection they want the final output to be delivered in, and use that. I'd suggest getting that confirmation in writing, since it's a bona fide change order or a variation. If you do that, if someone else decides later on a different projection down the track, then you've got something to fall back on. Technically, you could change it in RAS Mapper later on, but sometimes that really messes things up and takes a lot of time to fix, especially if you use projections that have heavy like rotation factors or other skews. A lot of mine have that since I work in local mine grids quite a bit, but I definitely recommend agreeing on the projection in advance. So don't just wing it for the time being. Changing it later could totally mess things up. Now, if you're already comfortable with projections, you might want to skip ahead to the next chapter. But if it's a new concept for you, maybe go back to this prequel setup video here. And in that video, we spend some time stepping through the background of projection files, where to get them, what's contained in them, and why they matter. We'll show how UTM zones are laid out, and we also talk about what the APSG codes mean, and some other details if you're interested in those. Now, just to drill in the point in face-to-face courses, sometimes I'll take a glass bowl, put it over the projector, and draw some shapes on it. Now, since I wasn't using a projector for this video here, I tried to do something similar with a flashlight. So either way, you should be able to see a curved shape projected onto a flat wall. And at least with a projector, you actually get pixels on the wall that essentially show the base units with an assigned north direction. Now, the video with the glass bowl in it, that one also links to another clip that I would definitely recommend watching. And this is Johnny Harris's clip on why all world maps are wrong. Now, I do something similar with an inflatable globe in our live courses, but it's just like a light shining through on the wall, and then we deflate it here like Johnny does, and then we see if there's any way to actually flatten this thing out. I ended up ordering one of Johnny's posters here, and actually shows why all world maps are wrong. And they shipped it out to me all the way here in Australia. I've got to get this one framed still. I thought the poster was just a very nice way to show why projections matter, and maybe you can see now why I'm using that as my virtual background today. So maybe it's time for another pop quiz. You see all these crazy shapes here, stars and spheres and all sorts of things. Pop quiz question is, what shape do you see here? Now it looks like a square, but if you want to try this for yourself, head to mathagon.org and you'll see that it's actually a triangle, at least in some parts of the globe. If you get near the poles especially. If you want to try some of these other tabs here for different projections, you'll get some really crazy shapes, especially along the edges. Now anyone can try this themselves in RAS Mapper. If I put a dot here in Perth, which is where I sit, and then put a line of longitude for my UTM zone, if we zoom out a bit, you can see it starts to get a little warped. I don't know if you know the shape of Australia, but it's curving off there a little bit. Now we see Antarctica down below us, and if we keep zooming out, you'll see everything getting more and more warped as you move around. So as you come around here, Saudi Arabia, there's Madagascar, there's the tip of Africa. If you imagine taking this line here and slicing with a knife through a globe and then trying to project it onto a flat map that way, instead of the poles getting warped like they do in most projections, you're seeing things on the side get warped, which is what happens when you project out to one of these UTM zones. So let's get back to our actual HEC RAS project. Again, to set the projection, we just go under Project Set Projection. Now you'll see this handy link here to spatialreference.org. I do like using that one. And spatialreference.org, we're going to be looking for Disneyland. So let's type in California here. And in our options, you get quite a few of them. So which one do we pick? I'm going to go with one that's in metric units, but what UTM zone should I pick? Well, let's find the projection zones for California. If you just Google it, you'll see a couple of maps here. We're going to be down in Orange County, that's zone 6. I think LA County is zone 7. So we want UTM zone 6. So let's go back to spatial reference here. There's a zone 6 one. I'll choose the latest one, the NAD 83 2011, and it's going to be EPSG code 6425. Now you can see a map there. Make sure you check that to see if you're in the right area. So Disneyland's right about there in Orange County. And so then if I go back up here to the PRJ menu item, you get one, it's called 6425. That's the EPSG code. And again, watch that first video to figure out a little bit more about what those mean. But in my directories, I already have a bunch of the ones for Australia set up. I'm going to delete all the rest of those because I like to have one projection file and only one to avoid confusion. But I don't like to just leave it as that name. So I'm going to open that up, and you can see there the details of what it's actually called. Check that it's in the right units, but I like to take the whole description of what that projection file is called. I'll copy that and I will rename the file with that file name. I do want to keep the EPSG code in there too, though, because sometimes there's little intricacies that you might miss if you use one that's got a similar name but is not exactly that same code. So now if I go back here and browse to that file that I have now renamed under my projection file, you see that? Oh, I've got an error. Why? Well, that's a deliberate error to show you the difference between PRJ project files and in the subdirectory for projections. There you go. That's the one you need. Again, check the units, make sure you're in the right one. And when you say OK, now it doesn't show you anywhere here that you're in that projection. So this comes to my tip number 1. I said we'd be doing a wish list, and that is to include somewhere in this menu the projection that you've assigned. Sometimes you'll get some errors, and especially if you've copied the files to another directory, you might find that it's gone blank again, it's lost its association, and so you might have to go in and reset it. But I think it would be very handy if somewhere on here, like in most CAD and GIS programs, you can see what your active projection is at the moment. So moving on, let's see, now that we've assigned the projection, to see where we're at, let's give it another shot with map layers. We're going to right click on this and add web imagery. I usually start with Google Hybrid. I might add some more later on, but let's see if we can find out where in the world we are at. We can see that RAS Mapper has pulled up the real world. So it's now projected onto a 2D screen with Cartesian coordinates. So that's X, Ys, or easting, northings, which you can see down here. So it looks like we're in the Pacific Ocean out here. So let's zoom in to Southern California and see if we can find Disneyland. Looks like it was zoomed in really far, but let's pan across here. I can see LA here and zoom in. So we've got a nice aerial photo in the background, but if we're going to want to make water flow, we're going to need to find the ground levels. Ground levels will show up under terrains. We've got nothing there right now. So again, going back to our Windows Explorer, under the terrain subfolder, it is blank. Now, usually you'll have something that you're starting with, in which case I would take any topo for the files you're going to use, drop them into this folder before you start the project. This folder can get really busy, so sometimes I put in subfolders with the acquisition dates just to help keep things organized. Now, for today's demo, I've started without any ready-made topo because I want to make sure we can all step through that completely from scratch. So let's download our own terrain data right here through RAS Mapper. Now you can define your area of interest in advance, or you can use the view window, in which case it's going to grab everything that's available inside that window. So I'm going to zoom out a bit here because at this point I'm not quite sure how far the water is going to go. So I'll cover the whole area here from LA down to Anaheim. So what you want to do is right click on terrain and download terrain data. Now you've got two options here. The grid option needs a US military login, so I can't demo that, but everyone can get to the free public data from the USGS. So let's see what they have for us here. Now I'll query the products for the current view, And they've got the whole planet covered with free SRTM data. That's the Shuttle Radar Topography Mission. You can Google that if you want to know more about it. But even though they've got the whole planet covered in their database with RAS Mapper at the moment, you can only download the data directly for the US. So here comes wish list item number 2. Maybe that's far-fetched, but I'm hoping the rest of us international freeloaders will be able to access all the areas outside the US someday. So it looks like it has grabbed over 8,000 data sources for us to potentially download, all different resolutions. I don't think we want the highest resolution everywhere. You might have studies where you want that. In our case, we just want to cover the overall catchment or watershed at a coarser resolution. If we go to the coarsest here at 30 meters, these are the 1 arc second tiles that are available for the whole planet. They do have, I think if we go to 10 meters, I saw some of these in here, the 1/3 of an arc second data. When you highlight these, you can see the coverage area. I'm going to grab the 4 tiles here that make up the whole area. So you can see it's all covered in green here. I would suggest putting in the 09 terrain directory, if that's what you've called it, here on the folder. Otherwise, it will create a new directory called terrain, and then you might it might get a little bit confusing which directory your terrain files are going into. So I'm going to go ahead and download these 10-meter tiles here. Looks like it's a couple of gigabytes. Now, gigabytes used to be scary, but these days, sometimes I get individual topo files that are 100 gigabytes a piece, just for one file. And HEC RAS can actually deal with those just fine, as long as you've got the space available on your hard drive. So I've got this open folder after download toggled on. That's by default. And so as soon as it gets done, we should see the topo files in the folder. There you go, it has popped up. And so when I close that, then we'll be able to see inside that folder. You'll see here the white cells here are where there's data, black is where there is no data. So now I've got my coarse resolution data for the overall extents. If I want to zoom in and see what we're looking at locally, rather than try to filter through everything that's available for this entire coverage area, I'll go ahead and zoom into our area of interest and re-query it. So there you can see Disneyland Park here. I'll zoom in on this, get a little bit closer, and now let's include the river channels here as well. And I'll go ahead with this new zoom extent, and let's figure out what we've got available to us in this current view. So moving ahead to save time, there it's done. And so now I've got my 1 meter right here and my 10-meter coverage. Now, before we continue with our workshop, I do want to hammer in a couple of warnings about using satellite-based coverage for hydraulics. But first of all, if you're working in other areas of the world, the PDF workshop guide that you see here that we brought you in part 1 has a section on accessing terrain data. It's for a tutorial project in Australia, which you can get from the Elevation Information Service. That's ELVIS for short. That's what it's actually called. I've got a separate guide for the LINS server in New Zealand that you can download at the same link. For other areas of the world, you may need to hunt down whatever government organizations or private data repositories are available for your part of the globe. I definitely want to stress that wherever your project is, you'll want to do your homework in advance. Find out what's available. There's nothing worse than finishing up a job and you find out later on that there was actually some higher resolution or more recent data that you should have been using in your modeling. If there's nothing else available, and this really is an absolute last resort, you may want to grab the SRTM data from the Earth Explorer website. If you want to step through these screenshots of how to do it yourself, you can check out this video where we go from scratch. We grab some data from outside the US, but we also grab the same spot here that we'll be using in LA for today's demo. There are a lot of other websites you can use to get to this data. In addition to the raw data, some of these actually let you access smoothed data. So if you do see SRTMH or DEMH as an option, that's the one I generally use. The H is for hydrologically enforced data that actually has the flow paths artificially burned in. Now, watch out here in Western Australia in particular, there are a lot of basins that actually in reality don't have an outlet. So they're terminal sinks, but the corrections get applied and we think they're being made to put channels in, but it's actually the coarse elevation data that might have missed the flow path, and those connections don't actually exist in real life. So that can really screw up your watershed or catchment delineations. It'll mess up the flow paths, the flow hydraulics. Pick very carefully when you're downloading. Now, sometimes I just grab all of the available data formats so I can refer to them later for comparison. But I'd always recommend doing a reality check once you've got the data. Now, I'll include some links to some sources that show the overall accuracy of SRTM data. The free SRTM data are available at a resolution of about 1 arc second, which is 1/60th of a 60th of a degree. So if you look at a globe here, have a look at the lines of longitude and see what 1 degree actually is on your globe. You get one data point. I think it's 1/3600th then of each of the 360 degrees around the planet. And that works out to be just one data point for each area that's covered by about 30 meters by 30 meters in size. So it's only 4 elevation points per acre for those in US units. So here in Australia, you can see from this figure that the vertical discrepancies can be 20 meters or more. In an earlier video, I showed how bad this can actually be by using the LA River. So if we take a cross-section plot with the SRTM versus a LiDAR surface, you can see here you've got this covered, even the low flow channel in the LiDAR, but the SRTM data just totally misses it. So when you look at some of these iconic movie scenes that have been filmed there, again, you're not just missing this low flow channel, you're missing the entire thing. So if we think about the demo that we're doing and the data we just downloaded in this part of the US that we're looking at, we've got 1/3 of an arc second data. So that's at a 10-meter resolution instead of 30. So you get about 1,000 square feet for each data point. It's about 10 times as many data points as the standard SRTM data, but as I understand, it's still shot from space. And sometimes the higher resolution data sets are just triangulated from the original data. And then HEC RAS will actually do the same thing for you. So it's not necessarily more accurate. So even though it's nice to see and helps with overall flow directions for your hydrology, the satellite-based data won't really help you much for flood delineations, velocities, depths. Imagine running this as your surface. We're going to need something more detailed. If it turns out that SRTM is all you've got, I would just put a stop point right there, go back to the client or whoever's looking for the hydraulic results, let them know you may want to get a drone up in the air or get some quotes from LiDAR companies to get better data. I wouldn't spend another penny, another hour on the job until you've confirmed that either you won't be getting anything else or you just don't have time to wait for it. And in that case, if you use it, put a whole lot of caveats around any results that you report. So if we go back into RAS Mapper now, we've got these files here. I do recommend trying to keep these a bit organized. So I'm going to take this and call it USGS 10 meter, and I'll make another one for USGS 1 meter. That just helps me keep things separate. USGS 1 meter here, and I'll just drop this one in there, and I'll take these 4 here and put them inside the 10 meter folder. So now if I want to come back in here and create a terrain, there's nothing here right now. I'm going to right click here and we're going to create a new RAS terrain. Now, the only difference between a new terrain and existing terrain is whether you've already got an HDF file. Hierarchical data format. If you want more information about HDF files, how to open them and view them with a free third-party viewer, check out Full Momentum episode number 32, which is all about the HDF files. So these, the terrain data, it already exists. We've just downloaded it, so we're not creating it from scratch. But if you had already done this before and you had an HDF file, you could add it as an existing terrain here. But if that's the case and it's already sitting in a different folder that's not under this project, I would copy the files, maybe clip them to what you need over here into this directory first so that you don't lose them if this project gets zipped up or transmitted to someone. So in my case, I don't have the HDF file yet, so I'm going to create a new RAS terrain, and let's go ahead and browse to our default folder here under terrains, and I'm going to start with the USGS 10 meter terrain data set. So the subfolders are shown here. I'm going to select all 4 of these, pull them in, and so now I've got these. You can see the cell size here though is obviously that's not in real units. You see the -05, so this is going to be in degrees. So this is geographic coordinate systems. A couple of things though to note here. The one 1/128th. That's the rounding or precision. I think that's binary. It gives you about a 1 centimeter accuracy. There are files that you'll get from people that have the DEM data down to the nanometer, which is just ridiculous, just wasted space. And so this truncates it very nicely. I do recommend when you have tiles that are next to each other that are all the same resolution, you could just merge them all together. Don't do this if they're overlapping or have different resolutions. A few options here for you under the vertical conversion. I won't cover those quite yet, but one thing I will stress is do not just leave this as terrain. And again, if you have the default directory here, it's going to create a new folder called terrain. I've already got one that I use for my terrain files, so I'm going to browse to that one. And when I go in here under the terrain files, I'm actually going to stick this one under USGS 10 meters, and I will call this SoCal 10 meter. So if you just leave it blank, you're going to get terrain, terrain 1, terrain 2. That won't be very helpful. When I hit create, it should reproject this then from the geographic coordinates into the well, it should project it into the projected coordinate system, but it looks like this particular projection file that we've used, it can't do it. So couple of different options we have here. We can switch projections, or we could go into QGIS and reproject it there. Again, you got to get out of degrees and into meters. So I'll close this up here and show you a couple different options. Now, one option to fix the issue is to pull it into QGIS. You just drag each of these tiles in here in their geographic coordinates, assign the EPSG that you want to see it in, and then you right-click, export, save as, and as long as you've got this one defined as the one that you want to see it in, you can just export it to wherever you'd like to see it. Now I want to keep this video standalone, so you don't need any other software, so we could do it in QGIS, but let's try it right here in RAS Mapper as well. I could also just cut this out and use a projection that works to begin with, and pretend like everything always goes right when I model, but that's not the case. Sometimes it's good to see errors. That's reality. So if I go here to set projection again, this will take us to spatialreference.org. If I go back to California and have a look at these, so this one did not work for us. A couple of other options. I want to be in metric units, the Harn high accuracy something network there. I'm not smart enough to know what all these terms are. I can Google them, National Spatial Reference System here. But in terms of which projection to use, again, I would go back to whatever your client wants to see, whatever the CAD drawings are in. Ask somebody who knows about these things, because sometimes if you're just guessing, you might guess wrong. So I think I'll go for this one here. It'll be, I guess, 3499. Let me try that one. And again, just go through the same steps that we went through before. Grab the PRJ file, and I'll just take this one and put it into my projection file or projection folder and rename it there. So I just took it out of my downloads folder, and again, I'll take the data that I've got here. That's the one I want there, and I will rename this one and include the EPSG code in it. There it is. Paste that in there, and I can say EPSG, and this is going to be 3499. And again, I think I mentioned before a warning not to ever change your projection. We haven't done anything yet, so I think we're still safe. So I'm going to close these out. We'll go back into RAS Mapper. Actually, I'll leave this open because I'm going to show how we're going to delete that one later on if this works. So I'll go back here to my projections, and in this folder, I now have the second one, which I've just grabbed, which is this EPSG 3499. And so if we try the same thing again, I'll go here to terrains, create the new terrain folder or file here. I'll grab all 4 of my USGS 10 meter tiles. We'll merge them together. I'll give them a name here. It didn't actually work last time, so I didn't put anything in here. So I'm going to call this SoCal 10 meter DEM, and let's hit create, and fingers crossed that we actually get this thing going. Okay, so there's another tip to maybe add some more projections that don't throw errors when we're trying to use them here in creating a DEM surface. And while this is running, let me pull this back up just to avoid any confusion. I'm going to delete the one that I'm not using. This is no longer referenced. It is gone. Sometimes this takes, 2 seconds, 10 seconds. Sometimes it takes all day long, depending on how big your files are and how good your computer is. So what it's going to do here then is create a couple of files for us that we'll then have a look at in Windows Explorer. Okay, so it just completed. I'll close this. You notice it'll resume to the whole coverage that we're looking at. We had Google Hybrid on. If I turn that off, you can see now we have this whole area covered. And if we go into our Windows Explorer, let's see what it has done for us here under the 10-meter data. So very important to be familiar with what these files are and when it creates new ones. What it'll do is if you had these ones individually and when it had not selected merged, you would have 4 different new GeoTIFF files that tend to be usually more compressed and more compact than what you started with, not always, but sometimes. And you will always have an HDF and a VRT file that are going to give you something about the stacking order and the extents and some of the metadata basically for how this is going to be displayed and what the hierarchy is going to be. Now we can look at this another way as well, which is just by double clicking here. I did want to mention that these GeoTIFFs right here, the original ones, these were in geographic coordinates. This should now be reprojected to the coordinate system that I've got. So I do always recommend double clicking on any terrain file that you've created. Go to the source files here, just check and make sure that this is what you want to see. You can always click on the info here, and again, just confirm that you are in meters on the one that it has now created for you, the additional GeoTIFF file that's now in this folder. And again, just note here that it says 10 meters. It's not exactly 10. When we start with geographic coordinates, you'll notice that the SRTM data set that's around 30 meters, it'll come out as 29 point something. It may be a little bit different than what is stated in the accuracy here. Now I could stack things to begin with here. I'm pulling them in separately just so I can see what I'm working with. We're going to do the same thing here now with our 1 meter data. So I'll go back up one folder up and go to the USGS 1 meter. Now this worries me a little bit when I see here that there's some data and some no data. Let's see if it actually covered us. Ideally, you'd want to see this as being completely white so that you've got data everywhere. So in this one, again, it's going back to the previous directory. I don't want that. I want to bring this in now under the 1 meter data here, and I'm going to call this USGS 1 meter, or I can call this, to be consistent with my previous one, SoCal 1 meter DEM, and the area that I've got here would be Anaheim. This will tell me a little bit about it, and when I hit create, don't have anything to merge this time around, so I'm just going to hit create and let this one come in RAS Mapper. So when it finishes downloading, it resumes me to where we're at. I can either turn this on and off to see where we're at, or I can double click and we can fade this back to see some transparency underneath it, and then we can orient ourselves and know where we are. Still don't see much of the relief. One suggestion, I wish they would just have this on by default because I think it's very handy to turn on, when you double click on these, turn on update legend with view, and that way when you zoom in, you can see the full spectrum of colors from the white snow-capped peaks as a global model would have it down to the lush rainforests. You see that everywhere, and it kind of makes intuitive sense in terms of what's higher and what's lower. So we can see now Disneyland here, a freeway running through the yard there. The berm around Disneyland shows up, but that's on the one that's on top. Usually we would stack these up so that you could see the higher resolution on top. So I can right click here, move the layer up. And what I'm noticing now is that even though we saw a rectangle there in the data that we downloaded, we don't actually have that here. So when I pull this out, we've actually missed Disneyland with this data set. So even though I wanted to just keep this completely standalone and not go anywhere else, I guess we have browsed around on some other websites. So let's try and see if we can find another data source. I guess we can't get it straight from HEC RAS, from RAS Mapper. So we'll need to find another data source for our higher resolution data. So if we're looking for free terrain data for Southern California, you could just Google it. One of the options that'll come up in the results will be generally the NOAA Data Access Viewer. I like that one. You could just Google it yourself, and that should take you to the interactive viewer here, and that allows you to download elevation or LiDAR data. If we click on that, you'll see the coastal areas covered. NOAA, the O in NOAA is for ocean, I guess. And so, yeah, the coastal areas are covered. Let's zoom in here and try to find some of the same extents that we were looking for through the RAS Mapper USGS download button. Let's find the park here. It looks like we're in Anaheim. There's Disneyland and California Adventure. We're going to be interested in water flow, so we want to make sure our area of interest also covers the adjacent river channels as well. So I think that extent's about the same that we were looking at before through RAS Mapper. And let's look at some of the options. If you try to, some of these will be the same as they were before in RAS Mapper, but if we just add it right to the cart or go to the bulk download, you have to be smarter than I am to be able to mess around with that full data set. So if we just go in, add this thing to the cart rather than going to the bulk download, you will see a few options here. So this is a 2011 LiDAR data set, and you've got a lot of options here. Now I don't want to be in feet, so I'm going to change everything I've got here to meters. And you could mess around with the grid size. I'm just going to leave it at the default. But what do you use for your classification here? So you got to go to the advanced options to see this. If you wanted just ground points, you could probably grab just the ground. First and last, that has to do with whether you're going to hit the vegetation or whether it's going to be the last returns that maybe hit the ground. Do you want water in there? Do you want buildings in there? I'm just going to go for any ground points, and I guess on the water, let's leave that off and see what that does. And so if I just hit next and download this, you might want to try some different options. I'm just going to put my email address in here. Do I want emails? Nope. And so now it's going to come into my email inbox once it downloads. Before I grab that, I do want to just cover one brief video here that we covered in part 1 of our original series, where we actually look inside the guts of the terrain data, because sometimes it'll give you a choice. Do you want GeoTIFFs, where the projection is embedded in it? Do you want ASCII data? What format do you want it in? And I think it's very important to understand the differences between vector data that is triangulated and raster data, which is what we're going to be accessing here. So back to our Windows Explorer, I have just grabbed from our downloads folder. I've grabbed the new data that's come in. I'm going to paste that right here under terrains. Now it tells me my job number and all this. Just so it's clear for everyone else, I'm going to call this my NOAA 2-meter DEM. And so that way I can keep that separate and organized. So let's go back into RAS Mapper now and see if we have any better luck with this one. I'll create a new RAS terrain. This time we'll go into our NOAA data, and you can see there is a bunch of black and white, which is, again, because of how we've picked which points we're going to include. We may see some no data values. In trying to keep this organized, I will go back up here and make sure I put it in the right file, and I'm going to call this consistency with the other ones, SoCal NOAA 2-meter DEM, and hit create now. You can see the cell size is coming out in 2 meters, and you can see the projection, which matches what was in the NOAA data viewer, but it's now going to reproject this into the projection that we have picked. So when I close this, you can now see where there are no data values. Now, if I put this one up on top and move it up there, then you'll see that the some of the DEM data from the 10-meter will pop right through. So this one, I'm going to just ignore that one. And now you can, it's hard to see where this is. And so sometimes I like to double click on this and plot the stitch tin edges. And then you can see everywhere where it's just seeing right through the 2-meter data into the 10-meter. That'll become a little bit clear here around Disneyland. When I turn off the 10-meter, you can see where, I'll turn off the aerial as well, you can see some of the data that's been missed. To see what those are, let's turn on our map layers, and let me just turn this on in a little higher opacity, One of the things that I wish they had here was, again, on a wish list item was a refresh, so I don't have to change my view. Maybe there's another way to do it if somebody knows, but if you just wake it up by moving things around, then you can see where you're at. So let's see what it missed. The water, obviously there, it's Tom Sawyer Island, so the water got missed, but some of this is the building. So there's Space Mountain, that got missed as well. Some of these are structures. I think the parking garage is there as well. So that's the car park is not in the terrain data. So big question then is, how do you want to reflect these things in your model? So there are, I would say when I first pull in a terrain model, there's probably 5 things that I check, that I typically check. And maybe I'll list these here in text on the video just so we can keep these organized. The first one is, how are channels or levees reflected in the DEM? And so if I come over here and have a look at this river channel here, the Santa Ana River, I think it comes down from Prado Dam. I used to live right along here, and I don't remember all of these little basins here. Let me turn on the map layers and see. I think these are groundwater recharge basins. And so you can see the water's not in there, but the bunds or berms in between the ponds are certainly in there. So you can see how this snakes around. So again, if I want to see what's in here, I'll probably want to use the measure tool, but oh, I forgot again. This is why I wish it was on by default. I can see a lot more of the relief here if I click on that option to update the legend with the view. So using this little key here for the measure distance command, I am breaking my rule here. I'm cutting left to right. I should be cutting left to right, looking downstream the other way around, but just so it lines up with the map here. Let's see, is this reflective of what's actually on the ground? If you had any sort of survey data, even just at one point, a photo, just a ground photo, even Google Earth Street View, something that tells you, did you get this channel reflected right in your model and in this terrain model? So anything that holds water or conveys water is supposed to prevent water from moving. You want to know, is it in your DEM, or are you going to have to fix up your DEM to build it in? So it looks like this has got pretty good resolution. Let's compare it here then to what's underneath. And maybe sometimes it's good to check your data sources here by cutting across the entire thing with both. And you can see the discrepancies are not as bad as we saw with the 1 arc second DEMs. But let's move on to our next item that I would always check, which is vegetation. So you might be a little bit hard pressed to find some vegetation in this part of California, but let's see if we can find a little bit here. Looks like there would be some trees in some of these areas, and what we want to know is, are they reflected in the terrain data? So if I turn off my map layers and zoom in here, it looks like vegetation's been pretty well stripped out. And so you can see if I had a tree that was 5 or 10 meters high here, you would probably see it come out if it hadn't been properly filtered out to bare earth ground levels, that last return rather than the first one. If they're not filtered out, then HEC RAS is going to treat them like dirt or concrete, same as the buildings. So let's have a look at buildings here. It looks like, again, if you had all the rooftops on there, this would look quite different. Some of the larger ones have not been picked up in this particular data set, but most of them have been filtered out to bare earth. Now, there are a couple of ways that you might want to deal with buildings in HEC RAS. We might talk about some of those down the track, but what you'll want to know first in terms of whether or not to remove them or put them back in is how you're going to want to model them. So make that decision before you start messing around with the topo. Now, the next thing I check is bridges and culverts. That's very critical for your model. You'll want to know, does your LiDAR, does your DEM include bridges, or have they been stripped out? And again, you'll want to know how you are going to want to model these before you make any decisions on whether to make adjustments. So in this case, you can see in some cases there's no data where some of the bridges have come out. In other cases, it's actually been stripped out and replaced either with assumed terrain or let's see if they've triangulated some of this. Sometimes you'll see where it's been removed and where building paths have been removed, you'll see the triangulations. So again, pay attention to whether bridges are in it. Here's one that's in. in, and that would be good. For culverts, you generally want the deck or the roadway elevations to be reflected in your terrain data, whereas for bridges, you're not going to want them there. And the final thing I'll mention here is water. So let's go back to Tom Sawyer Island. Oh, you can see actually going back to buildings. Is that Angel Stadium? Let's just see which one that is. So you can see the outline there. Yep, Angel Stadium. You can see that some of the bleachers have been removed there. So let's go back here again to Tom Sawyer Island and have a look around here at the water. So a couple things that we could check is even if you had water in there, you want to check the levels that it picked up on the day of the survey. So I'm going to cut a section through here and show what it looks like. And this is again one of my suggestions. It used to just stop when you got to the end. I do like that they've added this tracking button here. The little circle can show you where you're at, but there's actually no data here. So to interpolate from there to there, it can be a little bit confusing and misleading when we put these plots up. There's actually no data, it just stops there. And I wish there was some sort of symbol or something where you didn't see that in here. So now let's talk about what you would do if you didn't see reflected in your terrain the items that you want to see reflected in your terrain. Now the function that we probably want to use to start patching up things that we want to change will be the add new modification layer here. These are vector terrain modification options that you have. Now, I'm going to step through a few of these very quickly, probably too quickly to follow along with because I've got a whole video series on how to do this and don't want to take too much time out of the workshop to go through this in a lot of detail. But a couple of basic things that you want to be able to do. One is to put in a multi-point polygon and select how you want that to be reflected. So what are we going to start with here? Let's try Tom Sawyer Island with the water here and see what we can do. In this case, I'll just call it water. So we're going to zoom in here, and under water, the instant you put that in, it already starts editing this layer. And so what we're going to do is start drawing a polygon. So we've got this new feature button right here. It's going to come up with a little green light for us, meaning it's ready to go. And what I want to do now is draw in a polygon that's going to be the water surface. I'm not going to pay too much attention to my outer boundary, just as long as I've got this one covered. And when I put this in, I'll double click and it's going to ask me for a couple of different options. Now we'll cover all four of these momentarily with some features that we'll be adding for a hydraulic model. But if I'm just cleaning up the terrain, I'm not going to do anything with cloning or anything yet. We'll get into that. But right now I'm just going to replace these no data values with some actual values. Well, how high do I want to be? I'll just use a constant elevation, and we'll take the lower or the higher of the two. So it's going to take existing terrain where you've got some and where I've got no data. If this is down below the ground and at the water surface elevation, it's going to use that. But what elevation do I want to use? If I put it down at 0, if I go in here and double click on this, you'll see that it's actually left the no data values out, and it's actually not reflecting this correctly, which is a little bit odd. So if I want this value here for my elevations to actually show up, see that's 0, this is 40, that's 40. I might need to check around here and see what the surrounding elevations are. So I'm up at 42. You can see where I've got no data values. It's right where we get down to about yeah, maybe 40. So I'm going to change this one from 0 to 40. To do that, you highlight the layer that you want to operate on. This gets grayed out. I used to shut this down and bring it back up and stop editing and re-editing. All you have to do here, there's one more tip, to change is that you hit the arrow here. It covers up your button number 1, but you have to click down below it, and now you've got button number 2. I can right click on this shape now, edit the polygon, and now I'm going to change this to 40. So again, I think there's something wrong here. If I stop editing this and I cut a section through here, I should see it go flat at 40, and I don't. It should drop down to 40 and come back up. If I go along this point right here and measure along that section, you'll see that dot moving,
and it should be at an exact elevation of 40 when I come across. So another little tip here is to get that fixed up, because you want to see in your profile views, you want to see what HEC RAS is actually going to see when it runs water over it. Now, HEC RAS is not going to run with any no data values. You do have this option when you're drawing a modification layer on the polygons to just autofill all the no data regions. Now, it sounds really handy, but it'll start recognizing things around here that have been interpolated as being way below the surface, like 10,000 meters down below the surface. So in this case, it actually came out pretty clean. So maybe I'll take that back. I have had some where it glitches out and throws you with a whole bunch of crazy shapes inside of there. But it looks like that has been interpolated. I can leave that in or take it off. You can see now with the hierarchy that where I had water before, it has now put this one up on top of it. I can change this order around. I could take this now and move this up, improve or increase the priority level on this one. So this can get very complex if you've got a lot of different layers, but in this case, if I save this and put this other one over the top, then hopefully my water will show up above the filled no data. It looks like it's still triangulating it here. Let me try putting Space Mountain in as another polygon in this one, and let's just see if I can put a building around this one. There was a option on one of the previous versions that actually got removed that allowed you, instead of just having these 5 options, there was an additional one that only adjusted where there were no data values. So in this case, let me put a constant elevation of 50 around this one, and we'll just replace the terrain value here with that one and just make sure that we see that one coming up in the higher priority order. Now, I would clean this up, and instead of calling it water, we could call it building, but now you can see the building reflected in the terrain the way we probably should have seen the water reflected in the other one. So that might need to play around with that one a little bit. But what I'm going to do here, instead of using these filled no data regions here, I'm going to just remove this layer, and we can take these polygons out as well. What I'm going to do is, instead of using these individual shapes to define what's going to happen in the no data regions, I'm just going to stack these together now and pull in whatever was underneath in the 10-meter DEM, and that should take out everything down to the level that's actually there, rather than interpolating around the outside. So let me try that here with a stack. So everything we've brought in before has been individual files. We're going to go now and take a new RAS terrain, and I'll pull in the merged data set, which is this one here under 10 meters. So I'm not grabbing these original ones. I'm going to grab this new one here that's been merged. And in addition to that one, on top of it, I'm going to pull in the NOAA data set, which I've just created here. Now, every time you create a geotiff from a previous one, what's going to happen is it's going to get longer and longer with the file name. So it's going to be this, and then it's going to be this, and then we're going to add another one to it. So sometimes I go back to the original one just to keep the file name short. And it's going to get the name of the terrain, the HDF file that we're going to give it down here in front of the dot. So I'm not going to put this in a subfolder because this is now merged. This is going to be my Disneyland DEM. So this is just the combined one that I'm going to be using, and I could say existing conditions, but I'm going to use this same one to clone and put a proposed conditions on top of it. So let me go ahead and again have a look at this. When you see your higher resolution underneath, then that probably indicates a mistake. You can change your hierarchy order here. If I push that on top, now this is going to come on top. Doesn't matter elevation wise where these things are. This is priority wise. This is hierarchy wise. Which one is going to take priority over the other one? And so again, I went back to this one. If I had pulled in the second one that was renamed with the dot in it, it would be the same as the project. So let me create this, and we'll get a new terrain surface. Again, that resumes me to the full extents, and that gigabyte of data that I had is now back again. So let's have a look here back in the area that we were looking at. If I take this one here that's come in now at the bottom, I'll move that up to the top. This is the one I'm going to be using. Double click on this. I always update the legend with the view. And let's see our data sources. If I double click again and plot the stitch edges, then we should see where it has grabbed data from one source versus the other. So I'll see the outline of my 1 meter data set here, and I'll see everywhere that it looked inside of it, or looked right through that one, and saw the 10 meter data set underneath. So I should no longer have any no data values. It has triangulated in some cases because I've got a 10 meter resolution going down to a 1 meter, but at least now it should run with the hydraulics, which would otherwise fall apart when it hits the no data areas. Now, I don't know if I'll use any of these other ones. Sometimes I'll take some of these and just get rid of them. Remember, this one right here isn't doing me any good. You can either just remove it here, or you can actually remove it and delete the source files. It's only going to delete the new GeoTIFF, the HDF and VRT files. It's not going to delete your actual source data for it. So I'm going to get rid of that one because it didn't do me any good at all. Even these ones right here, I could have stacked them to begin with, and I guess this is another tip. It would be great if you could get some sort of preview. In order to even see what you're working with, you've got to make another copy of what you've got. And again, I've got files that are 100 gigabytes a piece. Anytime I stack them, anytime I bring them in just to preview them, it makes another copy of that 100 gigabytes. So just like shape files, we'll get to those in a minute, but shape files, you'll see a preview of where it is. It would be great if we could see at least a preview of what this is without it making a copy. Otherwise, what I usually do is just pull it into QGIS or into Global Mapper or some other software to have a look first at whether I'm actually in the area and have the area covered that I'm going to be working with. So I think I'll call it there. I want to keep these videos less than an hour. A lot of other things we could cover. I might cover a few of them when we get to putting the geometry together. But as I mentioned, I've got a terrain modification playlist here on the RAS Solution channel where we talk about some of these things in a little more detail, including what I'm noticing here. Again, a few years back, instead of the 4 options, we had 5, one of which was to replace the no data values and only operate on what shows up as the -9999s or whatever it is inside your terrain file. Now, pulling RAS Mapper back up again, if I take a terrain here and instead of working with existing terrains, I can actually create an empty one. And then from there, you can add terrain modification layers like we did here, and it's just going to be an empty layer with the polygons. Now, these can be as big as you want. It could be the entire thing underneath it, and you just put it higher than the highest elevation. And then when you stack them and put that fake new terrain in there in its priority level underneath the file that you're working with, the terrain file that you actually want to see, those no data values will show right through, and all of a sudden you'll have this big building. Or you could go down below and you could put basins in and just have any water that falls there in a rain on grid model could just accumulate there and not go anywhere else. So there are ways to remove no data areas from your model. But I think it'd be a lot more handy if we just brought that function back that used to be in RAS Mapper under the vector terrain modification tools. So thanks for watching. I know we've covered a whole lot. This was part 2, just RAS Mapper setup. There are a whole lot of other things we could have covered. Some of them we're going to put into part 3, geometry, as I mentioned, but we are going to circle right back through and come back with a whole nother part on how to view the results and how to interrogate those. A lot of other resources that you might want to have a look at. This one, sometimes you'll watch somebody else do a model and it's like, wow, I never even knew that was there because I hadn't looked. Look at everything, right click on everything, double click on everything, find out what the options are. Hidden Secrets of RAS Mapper, an entire episode, number 27, this podcast here. You'll see some handy things like tracing contours. And you can see a couple of other additional vodcasts here. Episode number 5 and 6 also covered some really cool features within RAS Mapper. So we'll see you in part 3. We'll cover the geometry and define where the water will flow. I'm off to the festivities. To get there, I actually have to drive along the actual highway to hell, if you're old enough like me to remember that album and that song. So we'll see you next time for part 3.